Hi, in this problem we're going to use Green's theorem to evaluate this integral. So here C is the boundary of the region between the lines y equals x and y equals x squared minus 2x. Let's go ahead and work through this solution. I'm going to start by writing down the formula. So it tells us that if we're integrating along C, then we have m dx plus n dy. This is equal to the double integral over the region R. And then here we have del n del x minus del m del y. And this is dA. And so here m and n have continuous first partials in some open region containing R. C is piecewise smooth. It's traversed once counterclockwise, and R is always to the left of C. So lots of information. However, in the problem, they tell us to use Green's theorem, so we don't have to spend time verifying everything. But once you see the picture, you're going to see it's really nice and clean, and it makes sense. You'll notice it's always to the left, etc. So let's start by identifying m and n. So this is our m. And this is our n. And so we need del n del x. So let's see. So del n del x, right? That's the one that's over here. That's going to be 2, right? Because the derivative of y is 0, because we're finding a partial with respect to x. So the derivative of x is 1, so we just get 2 times 1, so we get 2. Good stuff. Now we need del m del y. So del m del y. So we're looking here now because this is our m, and the partial of this is going to be 1 because the derivative of x is 0, the derivative of y is 1. Really cool. It's really fun. All the notation, all the del's, and it's just kind of, and you have this relationship between a single integral and a double integral. It's just really kind of fun. Okay, so let's go ahead and write down our problem again. So we have the integral along C of y minus x dx plus 2x minus y dy equal to, I'm going to go back to yellow. This is going to be the double integral over the region R. And it's just going to be 2 minus 1, so it's just going to be 1. So it's just 1 dA. And so the challenge now is to find the limits of integration. And that's usually the challenge. That's usually the hardest part. It's just to find those limits. So let's do that. Let's try to do that very carefully. So we have y equals x, and we have y equals x squared minus 2x. So there's lots of ways to start graphing this. I'm just going to draw the y-axis and the x-axis. Oops. And generally speaking, the more information you have before you start your graph, the better your initial result will be. Like I can just wing it and graph it here, and it might not be perfect. I might get the right answer, but it might not be a perfect graph. So let's do a little bit better than just winging it. So I'm going to start by setting them equal to each other so we can find out where they intersect. So we'll set x equal to x squared minus 2x. That's a good strategy usually in these problems. It's just like setting them equal to each other, because usually you'll get the points of intersection that way. Let's subtract x from both sides. That's going to give us, I'm going to come over here, save some room, x squared minus 3x equals 0. And then we can pull out an x. So x parentheses x minus 3 equals 0. Very good. And then we get x equals 0, or x equals 3, right? X minus 3 equals 0. You could just add the 3, no big deal. So that's pretty good. Maybe we should also see if we can find some other stuff. So basically we're going to have a line here. And so I'll go ahead and draw. I'm going to go ahead and draw the line. This is the line y equals x. Supposed to be a straight line. So I didn't draw the arrows because I want to indicate the orientation in our graphs. I'm omitting that on purpose. Normally you would do this, right? But I'm omitting it. And here's 1, 2, 3. So we know it intersects there, okay? And it intersects here. right, at 1 and at 0 and 3. And so this is y equals x. And then this one is a parabola, so it's going to come down like this and come up. So the big question is, where does it cross the x-axis? It's going to actually cross at 2. It's going to, whoops, let me just do a little bit better here. Come down really slow, really slow. Boom, that's perfect. And it crosses right here at 2. Not that that matters for this particular problem. I know that because if you plug in 2, you get 2 squared minus 2 times 2. So you get 4 minus 4, which is 0. So it doesn't really matter if you get that perfect, but I just wanted to point it out. And then so I'm going to shade in R. So this is R here. This is orange region. Okay. And the orientation here is counterclockwise. So I'm going to use a different color here just to indicate that. So it's like this. And it's traversed once. Okay. All right, so let's set up our limits of integration. So I'm going to come down here. So we have this here, R, and again, it's just 1 dA or just dA, but I'll put the 1 there. So let's integrate with respect to y first. So this bottom curve here is x squared minus 2x. So top minus bottom, or you could think of it from the bottom up. So x squared minus 2x. Right, this one's on the top. So it goes on the top. You can think of a rectangle if you want. Like if you had a rectangle here, you know, and you wanted to find the height of the rectangle, you would take the top minus the bottom function, and that would give you the height of the rectangle. So let me use a different color, see if I can show you what I mean. So here's the height of the rectangle, this yellow here. So the top function is x, the bottom function is this one, and you subtract them and you get the height of this yellow rectangle. And then x is, this is going to be dy. And then x is going from 0 to 3. So that'll be dx 0 to 3. Again, if you're confused, it's always just top minus bottom. It'll always work. And there's a 1 here. All right, so let me go down a line here. I don't know how messy this is. I haven't done this problem yet. I said don't wing it, and I'm winging it. So going from 0 to 3, integrating 1 with respect to y, we're going to get y. And we're going from x squared minus 2x to x. And then here we have the dx. This is equal to the integral from 0 to 3. And we plug in the x first, subtract, and then plug in this one here. So it's 2 terms, so don't forget the parentheses. X squared minus 2x, right? Be really, really careful there, right? Really easy to mess up. It's unfortunate, like, you know, you make it this far and like you make a little mistake. Hopefully, if you're doing this for like a class or something, the person, you know, grading your work is having a good day. So x minus x squared. And then there's really a negative 1 here, so we distribute that, we get plus 2x dx. Okay, everything looks okay. Talking about messing up, I don't want to mess up. Again, I haven't done this problem. So then we're going from 0 to 3. X plus 2x is 3x. So this will be 3x. And then minus x squared. So minus x squared dx. Really nice. Really, really nice. And now, you know, it's like straight up Calc 1, right? Use our Calc 1 skills. Use the power rule. So we add 1 and divide. So it'll be 3x squared over 2. Minus, and then add 1 and divide. So 2 plus 1 is 3. So you divide by that exponent 3. And we're going from 0 to 3. Ooh, we're going to get a fraction as an answer. Maybe. Plug in the 3 first. We get 3 times 3 squared over 2 minus 3 cubed over 3. Minus, and then you plug in 0 for all of these, and it's just going to be 0. So nothing there. So this is going to be 3 cubed, 3 cubes. We have 2 3 cubes. So it's going to be 27 over 2 minus 27 over 3. Okay, so I guess we should find an LCD here. So 6, I'm going to multiply this by 2 over 2, and this by 3 over 3. So, ooh, 3 times 27, big numbers, right? So let's see, 3 times 27. 3 times 7 is 21. Carry the 2. 3 times 2 is 6. 6 plus 2 is 8. Old school, 81. Also, you can do 3 times 20 is 60. 3 times 7 is 21. You add 60 and 21 and you get 81. So different ways to think about the multiplication. Lots of ways to think about it. I say think about it the way that helps you the most. Then 54 over 6. Okay. And then we just have to subtract 81 minus 54, which I believe is 27. I believe so. So if we do 54 plus 27, 4 plus 7 is 11. Then 6, yeah, 81 checks. Yeah, just gonna make sure. And so this will be 27 over 6. And I guess 3 goes into 27. 3 times 9 is 27, right? So this will be 9. And 3 goes into 6 twice. So 9 halves. Wow, a lot of fractions. Whoops, dropped my pen. A lot of fractions there. If I would have known that this problem was so messy, I would have worked it out beforehand. But 9 halves should be the answer. I will check this before I make this video, before I put this video somewhere on the internet. So if you're watching this video, it's correct. I hope this video has been helpful to someone out there who's trying to learn how to use Green's theorem. It's really not that hard. The statement is often intimidating, but you just use the formula and you set up the limits of integration and you're golden, right? I mean, if I can do it, you can do it. I hope this video has been helpful. Good luck.